Good morning, Year 6. It's Thursday, the 4th of March, and we're going to continue our work on solving missing angle problems. Now we're going to be using all of the facts we know so far about angles on a straight line, around a point, on intersecting lines and within polygons to unpick the answers to the problem-solving questions. We're going to be firstly looking at the question and unpicking what we can gain from just the diagram itself. And then we're going to be using bar models to show our understanding of how to correctly calculate the angles that are missing. Okay, so at this point in the lesson, you should have already started your arithmetic and have finished that and marked that yourself. And then we can go straight on to our main bit of learning. So, a bit like yesterday, you will find on your sheet today, having done your arithmetic practice, there's a space for you to just have a look at this question and think about what you notice. Before we even think about what the question is asking us to do, just have a look and pause the video to think about what do you notice in this diagram, what can you see, are there any angle facts that you can find within the problem just by looking at this diagram itself. So pause the video and have a go, just noting around like we started yesterday. Okay, so hopefully having paused the video, you've had a chance to think about things that you notice in this diagram. I started to pull out some information I thought I could spot that would be angle fact, that would draw on our angle facts that we've been learning so far. So if we have a look here, and one of the things that I've noticed, and you should have straight away noticed, is we've got a four-sided shape in our diagram. This four-sided shape, it looks like a square from what I can see. It hasn't got it marked that each of the sides are equal, but it looks like they are. Certainly a four-sided shape, and certainly that will tell me that the angles within it will equal 360 degrees. Also, I think I can spot, and it doesn't have the symbols for it. It might be because this is getting a bit more complex question, but I think I can spot that we have some right angles within this four-sided shape. I might need to get a right angle checker out or protractor out to make sure that that was in fact correct. However, I do think that looks like there are 90-degree angles there. So I'm going to make a guess that that might be some helpful information that might help me today in solving these problems. So I can also see, I'll start using different lines now so you can see some different colours. I can also see that there is a straight line involved along the bottom, but particularly I'm quite interested around these angles here, along this straight line, because I know that on a straight line it will total up to 180 degrees. So there's something there that's quite useful to be spotting at this point. I can see, I've just spotted that there is an acute angle actually in two of the places on my diagram. So I've started to kind of work from this side almost round the diagram, and I've spotted some acute angles involved in that. So when I start calculating my missing angles, if this happens to be one of them, I need to be aware that it's an acute angle, so it's going to be lower than 90, similar for the one up here. So I need to be using that to help me test and check what I'm actually getting to when I get to the answers in this missing problem question. I have noticed as I started moving around, I thought I was moving around the diagram quite nicely, but I've noticed that I have got an isosceles triangle here. So the things that tell me that this is an isosceles triangle is that I can see there are two lines indicating that the both lengths of these sides are the same. So it points to me to suggest that this third one is not the same, otherwise it would have that same similar symbol. So therefore I can start to deduce that we know isosceles triangles have two sides which are the same and also two angles at the same. So these bottom angles here, if you like, for looking at the triangle itself, are going to be the same, because this is falling as I think it looks like an isosceles triangle from the information I have been given. So that gives me a bit of further information that I can do, because I will know that whatever this angle measures, the same will be over here. And lastly, things I picked out, you might have picked out some further thing, is that I have got obviously a three-sided shape here. I believe it's an isosceles triangle from the information I've been given, and I know the interior angles of three-sided shape, three-sided polygon, total up to 180 degrees. So there's lots of information I've already got there. You might have got some additional information that you can see just from using this diagram and exploring all the angles facts that we have been using so far this week. So I'd like you to now just pause the video and have a think about this little extra bit. What could the question be asking us to find out? So you might be thinking, well, actually, I think that the question is going to ask us about this angle here. Some of you might be thinking, no, I think it's going to go for this angle, or perhaps this angle down here. I should have done that in a different colour, actually. So different questions it could be asking. There's a number of things that this question could be asking us to find out when we're thinking about missing angle problems. You might be thinking, it might be asking you to just very simply find the angle that is up here, if in fact it is what as we believe it to be. So it could be some simple answers to be gained from this question, or some more complex ones. So there's lots of questions that you can see it could be, and you might have thought of some of your own. So with all of that knowledge now, you will probably recognise whatever questions you did come up with, you do need some additional information to be able to actually attempt finding that missing angle. So now we're just going to have a look at the actual problem that this question came from. So the actual problem was this, and it was asking us to calculate the angle A. However, you can see at the top there's some lovely confirmations of what we've just been exploring in our diagram. We have got the fact that we know there's an isosceles triangle and there is a square. So straight away, some of the things that we would thinking through and having a go at exploring have been proved correct. We know also about this straight line that's there. So there's lots of information that it's telling you just from the introduction to this question. We were thinking that in order to attempt any of our missing angle questions that we were coming up with, we would need some additional information. So it has given us some additional information about this acute angle here, which will hopefully unpick what we need to be able to do to find out the missing angle. So it just asks us to calculate A on this problem, but you're going to need to do lots of different steps to get there. So go back to this to help you explore all the different things that we know already about the angles within shapes and angles on a line. And so with that in mind, your job, very similar to yesterday, is to have a look at this central problem, trying to work out what A it calculates, and then it adapts the problem through 2, 3, and 4. And as always, you've got your answers there for you to go through. There is a next one, task 3, which is just another what can you notice, which then goes into a further dip and pick task 4 question, as we've been looking at, but I won't go through that necessarily because we've just been through one with you, so you can see how you can explore it and what you need to do to get a sense of the question before starting. So as always, once you've done your calculations for today, your job is to send it in to your class teacher so they can see the progress that you have made. Goodbye for now.